Natural language processing is a branch of artificial intelligence and computer science in which computers are enabled to understand human language. There are two major parts of NLP, of which the major part is to enable the machine to understand the language at the document level. It is being used mostly in place. In the second part, the machine understands the audio and get insight from the spoken word and sentence inside it. But in this section, we will talk about NLP at the document level. In NLP, an attempt is made to understand almost every language and its type that an ordinary human being speaks, hears, understands, writes, and reads, and attempts are made to explain and train the computer through different medium within NLP so that it can provide insight or any conclusion by understanding the meaning of any sentence written in simple language. In the beginning, communication between humans and machines was tedious. The machine was designed to perform a specific task. It could not perform any other task assigned by a man without modification at the machine level. They were incapable of understanding human language. In the later developed computers, with the help of operating system, it became easy to instruct the machine to do any work through the code written in human language. But all these codes were written in a fixed set of rules, and it was necessary for everyone to understand and learn all these rules, which was not easy for the common man. An expert level person was required in this way. In this way, communication between machines and human was only one way. Today, with the help of artificial intelligence and computer science, efforts are being made to end the communication gap between machines and humans. Modern applications are capable of understanding human spoken and written languages. By using these applications, any common man does not need to understand any kind of set of rules to establish a communication relationship with computers. He can give instruction to the computer in single language and the result provided by the computer also in a simple language which he can easily understand. There are five communication agents in NLP through which we establish communication between human and computers. In speech recognition, computers try to understand what humans say and act according to the instructions given by them, as we see in Google Voice Assistants. Language analysis is basically converting what is said in one language into another language by a computer, as we see in Google Translate, in which we give a sentence or word in any one type of language as input, and the computer return the translation of the sentence in another language. Understanding in which language any sentence is written through Google is also a type of it. Dialogue processing basically refers to giving computers the ability to behave like humans, as we see in applications in the form of question answer, in which human ask a question to the machine in input and the computer answers it. The example of this is Google Assistant, which tries to answer the questions you ask almost like a human. Information retrieval enables the computer to extract some important information from a given input sentence such as name, location, and so on. Text to speech basically refers to giving computers the ability to understand any input text and provide its audio, as we see on Google. NLP has numerous applications and core technologies associated with them. The most important applications are machine translation, information retrieval, question answering, dialogue systems, and information extraction. I already talked about these. Summarization is basically the summarizing of a text by computer without losing its information, just like humans do. Sentiment analysis, this is getting the emotional index from the text and scaling it to a predefined or statistical scale. Sentiment analysis application you can see in online retail reviews, where reviews are displayed as poor, good, neutral, or similar to the scale. And in the core technologies, language modeling and name entity recognition, I already talked about them. And a few of the rest we will discuss in the rest of the session. Language processing has basically these five parts. Words and their forms, like morphology, are the basics of sentence. Part of speech is how grammatically a sentence is formed. Syntax is how words are combined to make a meaningful sentence. Semantics is how a word relates to other words within the sentence and with the whole sentence. Discourse is mainly about getting the meaning of a phrase from a sequence of the sentence. The word is the basis of the sentence. Its comprehensive meaning is required for the clear meaning of the sentence. Word level information is required in language modeling, tokenization, and spelling level correction. As in the example, while translating from English to Japanese, much information is required about what a red umbrella and small umbrella are called in Japanese. In another example, a spelling error is displayed. We have seen it in many applications like Grammarly where you get a real-time error alert for your spelling mistakes. In these applications too, the computer needs word level information. Morphology is basically the study of words, how they are formed and their stem and root information. In languages, word may or may not have different meaning by applying prefixes or suffixes to the root words. Removing those prefixes and suffixes reduces the computational cost. So morphological information is important in language processing. Part of speech is understanding the grammatical structure of a word in a sentence. That is, the word is a noun, pronoun, verb, etc. The information is crucial when extracting some particular information from the text. Syntax or syntactic parsing is the study of how words are combined to form a sentence. Word structure in a sentence provide crucial information regarding the meaning of the whole sentence. Semantics is the study of word relationship with the other words within the sentence and with the sentence itself, and also a sentence relationship with other sentences within the phrase. Semantic helps to understand the exact meaning of the sentence without the limitation of a bag of words. Even with a small bag of words, with the help of semantic information, we can clearly understand what a sentence is talking about. As in name entity recognition, while extracting name from the text, it is not possible to have all the name in the world in our bag of words. But with the help of semantics, it is easier to understand that the particular word is the name. A single sentence may have a complete meaning in itself, but it cannot signify the whole sense. To understand the whole sense, prior and posterior sentences are needed. Comprehending a sequence of sentences to get a clear idea of what the subject is talking about is called discourse. In NLP, we use this in summarization, sentiment analysis, etc. Syntax and semantics combined provide crucial information in the sentence. Otherwise, it is hard to get this from word level information. The meaning of a sentence and the meaning of a word within a sentence are both clear from these two indications. In this example, these three questions have answer within the sentence information. Who has the telescope? The woman. Who or what is wrapped in the paper? Telescope. An event of perception or an assault. Its event. And many more questions could be suggested and answered with the help of only the sentence information. These three approaches are very famous in NLP, and according to their time, they have provided satisfactory results to a great extent. Data-driven approach, statistical approach, deep learning approach. In data-driven approach, data is prominent. Copra is basically a collection of text. You can basically consider it as a dictionary. A lot of text is collected in Copra. Even the small ones have billions of words. It is studied, and on the basis of this study, an analysis is prepared and the results are generated. This text can be of any type, labeled or unlabeled. They are annotated in the same way, which is why the analysis provided by them is not much different. Some example of this are shown here, but there are many problems with Copra. Number one, there is a lot of text stored inside it. It is not possible to extract information from a small amount of text. Most of the text that is there is in a fairly consistent form, but people don't use language in the same way all the time. So the analysis from the Copra isn't very useful in real time. Second, Copra have a lot of language and spelling mistakes that need to be fixed. If we want to customize the annotated Copra, then it is not it is not practical because it is very expensive. The statistical approach is more practical and effective than the rule-based approach. In this, a lot of data is studied, probabilities and statistics are accumulated with respect to the relevant problem, and results are obtained accordingly. As Vadar did in sentiment analysis, in this Vadar has studied many words, and according to them he has determined some number or probability on the basis of sentiment. Whenever sentiment analysis of a sentence has to be done according to the Vadar formula, the statistical number or probability of all the words inside it is retrieved from the Vadar dictionary. And according to collective probability or statistical number of the entire sentence, sentiment score is determined. This approach has some drawbacks, such that the fact that a lot of data is studied for this, and secondly, the semantics of the sentence are not studied in it. The results based on the words are often not correct. The meaning of the whole sentence does not match the result. Deep learning approach is modern. In this, neural network is trained with which is similar to the human brain. Its biggest advantage is that manual feature mapping does not have to be done. It is capable of extracting features by itself while training the model. Due to transfer learning, a lot of data is not required, and a very accurate result can be obtained even with small amount of data. BERT is its most famous example. But its biggest problem is that its computation cost is very high, due to which it is not which due to which it cannot be trained on ordinary computers. Let's discuss a few challenges in NLP. Ambiguity is basically when the general meaning is not clear with the simple examination of the word or sentence. Ambiguity can be of two types. Lexical meaning means multiple meaning of word. For example, a bank organized a loan mela on the bank of the river. The word bank has two different meanings within a single sentence. Another one is structural. Basically, when the whole sentence depicts multiple meaning. For example, I saw the boy with the telescope. The sentence feature may meaning of a boy and a telescope relation. In another famous example, the depicted meaning is a whole lot far away from the general sense of the sentence. Every 15 minutes, a woman in this country gives birth. The famous depiction done by Groucho Marx is every 15 minutes, a woman in this country gives birth. Our job is to find this woman and stop her. Sparsity is basically the frequency of words in a dataset. It is usual that even in larger datasets or corpus, there are some words whose frequency is high and some whose frequency is very low compared to the normal ones. It means the trained model will always be more familiar with high frequency word and leave out low frequency word. This affects the accuracy of the model. Variations. Suppose we train a model on a news dataset and try to make prediction over a related social media post dataset. Then certainly our model fails in many ways. As social media posts have a lot more linguistic noise than news stories, which are collection of structured and correctly spelled sentences. Expressivity means having a similar meaning of different sentences. As in the example shown, she gave the book to Tom versus she gave Tom the book. The meaning is clear that we are talking about a female who gave the book to a person named Tom in both of the sentences, similar in the other two examples. And that concludes the discussion. Please accept my gratitude for your time and consideration. Additionally, I appreciate everyone whose work I have borrowed. Thank you.